we're going to talk about today is the natural variability in the bays. Now, the reason why we want to do this is we were talking, and you guys always ask me about ecologists, well, how's the bay? And we always go, and we try not to answer that. You've seen the shrug. The reason is if it's a drought year, it's a terrible year for oysters, but it's a great year for oyster drills. We're in a balance. So what I want to do is show you some variability. Now this is data heavy, so everybody who knows anything about a good presentation would tell you this is too data heavy. You have too many graphs. They're not wrong, but what I want you to do, we're not going to get mired down into these graphs, right? What we're going to do is look at how they differ from one another, the variability. And so you'll start to understand why when you ask certain biologists or ecologists, is the bay healthy? They go and don't want to give you an answer, okay? But what you can do though from here is build on this. What I'm hoping from this is you say, hey, I want to know more about this particular variability, then we can take and in a future date go in depth into that variability. So this is that high level variability of all sorts of parameters, not all we have, but a whole variety of them. And then, like I said, at future times, if you say, hey, I want to know more about that, we can drill in, because that's how we ecologists work. Fair enough? You game for all this? I want to hear a woohoo! Woo! Alrighty then. All right, so first thing I always like to remind people is Earth is a closed loop system. You all know what that means, right? Essentially, there's nothing new going on. You have a single ecosystem. It's called planet Earth. Essentially, there's no new water and land. Now, for the smart people in there and say, well, Hawaii has some volcanoes, so there is new land being created. You are right, but it's still magma from the center of the planet coming up. So that planet is simply a closed loop. There are some variations. We have a little bit of water coming in from asteroids and whatnot. But essentially, functionally, and I'm a very pragmatic person, it's a one loop system. Never forget that when you talk about what's happening in my bay is we have to go back to this far. All right, so we have large scale impacts. You all know tides, right? So anytime you're talking about bays, the Bay of Fundy has these huge, 14 feet, 28 feet tides. We don't get any, we get a 1.5 foot tide and we think we're a big deal, right? Woohoo, right? But we're not. So that's some of the variability that we always take into account. Y'all recognize we have seasons depending on which way our planet's leaning. Whee! You also have heard of El Nino and La Nina. So again, you have these systems affecting the entire planet that have localized effects. Never forget that when you talk to an ecologist, otherwise we go, right? We look like it. So, you know that there's, you've heard of El Nino and La Nina. Who here remembers that from 55 years ago? 55 years? Did you know it was called El Nino and La Nina? Maybe not. We're now calling it ENSO and a variety of other things because we're learning more and more. But you see in different years, depending on what planet Earth is doing, we have warmer temperature. El Nino, we're going to typically have cooler temperatures down here. La Nina will be warmer. Normal, you see it changes both temperature and precipitation on a local scale. So again, now you're starting to see why we ecologists twitch when you want to talk about one bay's health, because this is all involved, right? So seasonal impacts. One of the things you guys know this is, they're not learning anything new here, but just that all these dominoes stack together, right? When you have river flow, base flow, high pulses, overbank flow, subsistence flow. All that's natural, right? Part of the problem we have in Mississippi is that they trapped all that sediment, so the delta's, disappearing. You've all seen that, you have flood months, you have dry months, and so you guys are all familiar with this, even if you haven't put together that it all has an impact on our bay. Okay, we have incidental events. I think I'm not sure which tropical storm this is, but we have incidental events that come up, and For instance, with barrier islands, you have a hurricane, it can blow and does sometimes blow a whole new opening in a barrier island that didn't have one there before. Everything changes. We had that happen in Alabama, and the critters went from being bay critters to being nearshore critters overnight because of that. Amazing stuff. Planet Earth, you gotta love Mama Earth. She's really cool. She's also sometimes very cranky. This, if you don't recognize this satellite image, I'm just going to take a guess. Does anybody recognize this one? Can I bring back February 14th, 2021? Yeah. This is Uri. This is, So we had that. We all went out. We were taking fish kill assessments. We talked about that last time I was here. So again, all these have an impact on our bay. And we haven't even gotten to the good stuff yet, right? So now I'm going to take, and we've drilled down to knowing that that big picture stuff is always back there, to the Texas bays and their hydrological variability. That just means water. Oh, but that was a terrible slide because I put this in here. One thing you know, especially with Texas, Galveston clearly is getting more precipitation. Sabine's here, Galveston's here, East Matagorda, West Matagorda, San Antonio. But you can see the precipitation changes. Again, you guys, nobody learned anything, right? Y'all know precipitation changes, like West Texas is not the same as East Texas. But it also clearly is going to affect what? The bays. So, again, do we understand why ecologists twitch? Natural subregions. Again, you would think soil, well, in this case, did I bring my soil today? I did not bring my soil today. But this is the type of plants. So over here, you're going to have some pine. Here is the coastal prairies. But you see, you start to change as you get down here on the south part of the coast, right? Again, you all know this. You've seen it. You've registered it as a land process without realizing it, that there's implications for what kind of soil, what kind of habitat is around your bay, to how healthy or what you can expect from your bay. This is all making sense, right? All right, we haven't learned anything new, I know. All right, I did show you this slide way back when, about a year ago. This is where we have inflow from our rivers. And again, nothing new. You saw how we have more precipitation, at Sabine and Galveston. It's not surprising we also have more river flow. Now, river flow and local rain are two different things. What will have more impact on your bays is river flow more than rain. Like that little thing, all it did was make my hair frizzy. It didn't do anything to the bay, right? A local rain, especially if it's a light rain, will just mix in the surface of the water and glass off down, next time there's a tidal change, right? It doesn't change. You need river water. If you have a flood in Austin, it's going to make a huge difference to Matagorda, right? Flood in San Antonio makes a huge difference to San Antonio on the globe. So this is the Lavaca, Colorado. You can see that Sabine, it's a lake, right? We don't even need to talk about that. We have Galveston here. We have Lavaca, Colorado, the Guadalupe, Mission Aransas, and Oasis. So again, what you would expect from each of these bays is going to be what? Variable, right? So now we've had this before where I like to define estuaries. Anytime you talk about bays, estuaries. An estuary is a body of water formed where fresh water from rivers and streams flows into the ocean, mixing with the seawater. Although influenced by tides, estuaries are protected from the full force of ocean waves, wind, storms, by barrier islands or fingers of land that surround them. So you have to have this mixing, right? But this mixing is an exciting, cool mixing. It's like I have my ginger ale here, and I got my maraschino cherry here, and I mix them together, and I have a Shirley Temple. Come on, guys. I couldn't bring in any of the good beverages, right? I'm on the clock. So, but anyway, you have two good things, but you mix them together, and you get something even better, right? Tequila and margarita mix. So, but one of the things is we have a salinity gradient, again, closer to the river, could be fresher, closer to the mouth of, to the pass out in the ocean. Obviously, it's going to be saltier. But that river water brings nutrients. All that river is flowing through all those different soils and pine trees and whatnot to get down here. That's nutrients, right? That's not junk. That's nutrients. It might look like mud, but it's nutrients. It's exciting stuff. You have sediment deposition, and all this creates habitat and erosion protection. So you have a lot of going on, but when you have that nutrient loading, that's the exciting part. Because that means nutrients, are they uniformly distributed throughout the bay? We're not going to focus on this because this is not my area, but they're not uniformly distributed throughout the bay. So what do you think would follow? If your nutrients aren't evenly distributed, neither are your critters. So you always have to make sure that you're looking at these long-term patterns, which we will get to. So you remember from last time I was here, this is what we do. We do these 3 gears year-round. You've ever seen one boat sitting out the ramp on a day that no same person's out there? Look on the side, it's gonna have a skate logo, it's gonna be us, right? Well, you're not always saying, we try to be saying, and then this one, because it's adult fish, we take this 10 weeks in the spring, 10 weeks in the fall. Now, the reason we do this is oyster dredges target oysters, right? Otter, seines trawl small critters. Now, you gotta remember, there are some flatfish that they're no bigger than this at their adult age. So we're seeing adults in there, but we're also seeing small trout, small redfish. So we catch them in here. We're trying to see their whole life cycle. Otter trawls, we get bigger fish. But what's the interesting thing is a trawl can only go so fast. They refuse to give us a 200 twin 250s on really small. They don't want to do that. No, we draw a lot slower than that. So what? Do you have fish that swim faster? That gear was never designed for tuna, I assure you, right? So you have to say, okay, so I'm getting some adults here, but not all species, because some can miss it. And that's where this comes in. This is where we get the adults. And I think I told you last time, if you were an alien species, come to check out humans, find out everything you can know about them. Would you sample just a kindergarten? You want to get a good idea of what we're doing, right? You have to have all of the gears to put together. Even then, we do miss some species, such as what like Dr. Montagna does, the in-fauna, but this is enough on our plate, and we've been doing it over 40 years. So it's exciting stuff. I started when I was 2. So one of the things we're going to talk about is we're talking about this variability and the source of all this variability and why is my bay healthy and ecologists do this, right? So, but I want you to look, this is from over 40 years of data. I think this one is going to be from 1981 to 2021. Okay, so pretty long data set. These are, blue is fresher water, or lower temperatures, 10 to 16. Orange is higher. But you can see, as you're up in Sabine and Galveston, you have a lot more variety. Than you get down here, you get a lot more orange, right? Common sense. Now, if we were to do a seasonal thing here, you might see some variability, and we can do that. But you need to know that we have that data for 40 years, and that's the data we've been collecting. Every time we're out there with any of those gears we showed you, we're taking temperature, salinity, dissolved oxygen, and turbidity. Okay? Everybody know what turbidity is? You guys have been to these meetings long enough, right? How much, how chocolate brown it looks. All right. So this is our salinities, and again, exactly what you'd expect. Sabine, way up there, their starting salinities from 0.2 to 18. Galveston, you can see it still has that freshwater corner, and this is a 40-year average, okay? We can delve down when we want to, but this is just the 40-year average. From the trawls, trawl temperatures are taken about a foot off of the bottom of the bay when we're out there. When I give you same temperatures, they're taking the top 6 inches of the water. So that also shows you different stuff. Is anybody excited about this cool data yet? But remember, we're not delving into the data so much as recognizing these sources of variability so that as we go through, we can either drill down on certain aspects, or as we're talking to other speakers, we can say, is that all that's going on, right? So this is trawl salinities. This is seine salinities. Like I said, seine's the top 6 inches. We're out there walking. And you can see, you don't see the variability, but definitely you can see the delta's influence. The Guadalupe Delta is right there. You can see its influence of a lower starting salinity. The same with the Lavaca Navidad, Tres Palacios, and the Colorado River. Okay, so you can definitely see there just from 40 years average data. Isn't this cool stuff? I'm excited. All right, so here is dissolved oxygen. We all need oxygen. Now there's a chemical reaction with oxygen you probably already know. It's the same as when we were all in high school. As a liquid gets warmer, it can hold less oxygen. All the molecules are expanding. Remember that? That's what that water molecule does. It expands and elbows out everybody. So in the summer, you're going to have a lower dissolved oxygen naturally. It's not a bad thing. It's not a dead zone thing. It is natural. So, and then when it gets cold, they can hold a lot more oxygen. And it also, what it also affects is particulates in water. But you can see there's a lot of variability over here, but you know, that's because of, if we start to break this down to prevailing winds, you might start to see some trends that way. This is cool and exciting stuff. If you look in closer, you can also usually follow when you're close to the ship channel, because the ship channel funnels that ocean water coming into the bay. And so at the bottom of the ship channel, it's going to be a lot saltier than on surface, because the saltier water weighs more than fresh water. So you have your salt wave. But like I said, as we can drill down into our data, you can start to see seasonal patterns. You can actually, like I said, locate certain, ship channels based on stuff like this. So know that that data is out there. This is turbidity. And you can see it's variably murky. Yeah, I know, but that's just variably murky. You can see you have clear water here, which you would expect, because this is where you can see our seagrasses are where it's a lot less murky, right? Because if it gets too murky, they don't get enough light to do their photosynthesizing. And so that's what we see going on. See, I haven't taught you anything new yet, but you're starting to see why, I think this is all important. Now this, I'm going to start giving you some graphs. I don't want you to focus on the specific graphs so much. It's that they're representing the variability. This is 1982. This is 2021. Major bay codes, and I got called off to do other things today. So this is, blue is Sabine, dotted line is Galveston. They're together when it comes to temperature. Does that make sense? They're all farther north. They're a cluster. You can guess what these two colors are. Lower Laguna. And then there's the rest of us squinched in there. If you want to know, San Antonio Bay is this dotted black line. And this weird pinkish line, that is Matagorda. And then East Matagorda is this dotted green line. Watch the dotted green. Well, she's not always dotted green. I tried to be consistent, but this was made over weeks. East Matagorda Bay will flip-flop. Right now, she's all smooshed all in there with all the middle bays. But sometimes she's going to, I'm free! I'm a beautiful bay. I'm young and beautiful. I'm going to go and I'm going to dally, and I'm going to be more similar to, say, the Laguna. We'll get there. But I want you to watch that this is what we're talking about is how things vary. So this is average annual same temperatures, again, top 6 inches at the edge of the thing. And this color is East Matagorda, and she's trending together. You can see Sabine down here on the bottom. It's doing its own thing, average temperatures. And you can see this is Lower Laguna. So you can see, again, we have these trends, and clustered in the middle is Matagorda, San Antonio. Again, nothing we wouldn't expect. Average salinities for Texas bays, again, clearer, that you can see the differences. And okay, yeah, this is not yet. But you can see in the drought years, you know, I'm talking about sometimes East Matagorda Bay, it's up here, it's actually above, Lower Laguna for its annual, salinity. Cool, huh? You don't expect it to be, you don't expect East Matagorda Bay to be saltier than Lower Laguna Madre in a drought, would you? But it is. Pretty cool stuff. All right, dissolved oxygen, it's a mess, it's all together. But it's influenced by temperature and a variety of things, wind, speed, direction. This is troll temperature, we're talking about near the bottom. And again, you can see the blue and the striped blue on the bottom are Sabine and Galveston, and then pink and yellow at the top are Upper and Lower Laguna. And I want you to see where East Matagorda Bay is. She's this dotted green one here. You see where she is? So sometimes she's down here flirting with all the other middle bays. Sometimes she's off doing her own thing. Isn't this great stuff?
That spike on the left-hand side, what does that represent?
Actually, if I was to do it again, now that spike is as we were starting up the program, and I actually wonder about their thermometers. Of course, the other one started low, so I haven't investigating that, but it would be a lie to chop it off. But sometimes scientists do in the first year or two will chop off the first couple years of data, just because, you know, people were still figuring out how to find locations, you know. But in this case, I'm going to show you everything. So we don't know what that is. Also back then, that was program started real early 80s. Is how good was their equipment? You know, how precise was their equipment? Sometimes I know I ordered a meter stick, and it had to be a meter, and you know, with each millimeter, and it came in. It was in 2 millimeter gradations. I'm like, well, we can't use that. You know, we just couldn't. So what equipment did they have handy? We were just starting out. So annual same temperatures, again, what you're starting to expect, right? But notice that now we're talking about same temperatures. Suddenly you see Sabine's doing its own thing and Galveston's up playing with, you know, mid-coast, right? And then it becomes a total mess in the last, you know, 5 years or so. Pretty cool. All this to show there's variability just in the bays, just by what's naturally occurring. Why did I give you so much salinity? Again, salinity, did I double dip those? Dissolved oxygen all together, okay. But here's a cool thing. Matagorda Bay has, count them, 24 minor bays. We have Tres Palacios, we have Cox, we have Keller, we have Lavaca, we have Powderhorn, we have Swan Lake, we have Redfish Lake, and the other Redfish Lake. We have Karonko, we have Turtle, okay? Need I go on? So when we're trying to look at what's going on within our bay system, we also have to understand that by minor bay, there's also these differences. So this is, I took out a lot of the minor bays for you because it was even messier. But again, you just get the sense that some of these minor bays are doing their own thing. That one is, not entirely sure what that one is. 620, let's look at that one. I think this is 620. That's the pass. So we make Pass Cavallo, it's its own minor bay. So you can see there's variability, so you can't necessarily compare straight from one bay to the other. So this is monthly Matagorda Bay trawls temperature, and this is for Matagorda. So if you just look at Matagorda, this is a beautiful representation of the average monthly trawls. Do you like my new type of graph? A lot easier on the eyes. This is smack dab in the middle of the data. This is 25%. This is top 50. This is 25%. This is the top 50. This is lower 50. These are outliers. Okay? So it's just a different way to look at data that gives you a better sense of the average. Now so you can see this is Matagorda. But wait, there's more. So this is what we just looked at. This is still that same graph. Over here, this is Turtle Bay. This is Tres Palacios. Come on, there are similarities. Are they the same? So even though it's one bay, Matagorda Bay, East Bay was totally ignored, you can see there's extreme variability in these minor bays. And it has to do with how close are they to their river? How big is the river they're close to? Lavaca Navidad is bigger than Turtle and Tres Palacios, but not near as big as the Colorado. Common sense. Again, I'm not teaching you anything new at all. I'm just reminding you of how everything you already know works together and why it complicates my soup. All right? So, again, that's Cascavallo. And you can see, as you would expect, temperatures differ from the average of the bay. Variability is greatest in December. On top is Cox, below is Keller. Even Cox and Keller as close as they are. Do you guys like the complexity I bring to your world now? Come on, give me a shout out. But you can see, even though they're all Matagorda, and all of these data go into this, you know, all I did is take it out. That's the whole enchilada. That's everything that was sampled in Matagorda Bay for 40 years. That's the average for that. But that's the average for Cox for that same 40 years. That's the average for Keller for that same 40 years. And they're different, aren't they? What else do I have here? All right, we're gonna look at temperatures. That's Lavaca Bay. So that's the same. We're still working on temperatures. That's about a foot off the bottom. And off the bottom is gonna be more uniform than at the surface, right? Less mixing, less wind, you know, less people frolicking. And again, there's your Lavaca Bay versus Matagorda proper. So,
That looks really similar except for December.
and isn't that cool?
Yes.
You know, and then like I said, so what you do is you delve down into it. And that's what I love about our data set. You know, what we found with this data set, it's, in the first 20 years, we found, hey, it starts to look like for some critters and things, there seems to be a 20-year cycle. Now at 40, we're starting to see, for some processes, we're starting to think there might be 40-year cycles. And think about the glaciers. They came and they went over, what, thousands of years. So it's, Mother Nature has these long cycles. We just think it's long if it's lunchtime to supper time, right? But Mother Nature, she doesn't care about us. She still has these processes. But you can see where Lavaca Bay is running. It is similar, different, slightly different trends. But like I said, that's the kind of data that we provide and collect and love. This is monthly salinities, again, 1 foot off the bottom. This is for Matagorda as a whole for those 40 years. And you can see it's pretty uniform, and you guys know that that's crazy, but when you add 40 years of data together, this is what often happens. This is the average, right? But it's not necessarily reflective of what we know we see in Lavaca Bay, right? Because we average so many things that at a certain point, while we're sure this is good data, I do not doubt it, it's been averaging Cascavallo with upper Lavaca, fresh with salt. What you're gonna be in the middle. So that's what you're seeing here. So we would run different types of tests on this to find out what was more accurate. This is just purely, we broke it into quarters, okay? There's Cascavallo, as you would expect. It has, also one thing to watch, and I tried to convince you guys here, always watch when you see these graphs, what this axis is, and if it's the same from graph to graph. Sometimes for us to make sure you can see the variability, I had to start my graph at like 20, so you could see it, otherwise it just was all spaghetti to graph. But always look at that, so you can see that these are slightly different. This one, I didn't mess with this one, but this one, this is 15, so this is gonna be about, 12 to 40. So this is actually a little higher. So always be careful of watching your graphs when people are telling you that their graph is awesome and tells you what you want to hear, or what I want to hear. All right, salinities, again, up is Cox, down is Keller. They're all on the same scale here, so you can see, or you're starting to see that variability. Look at Cox, where that midline is totally, moving totally different versus what you have over there on the monthly. You can see also with Keller, you can see a lot of difference and variability. Okay, and again, focusing again on variability, this is Lavaca Bay. Now, part of what goes into this too is a lot of times you see a graph and they'll have the word N, the letter N. Do you all know what N means? N is how many samples you take. We take a lot fewer samples in Pascavallo than we do in Lavaca. Lavaca's bigger, Pascavallo is small, right? So a lot of times you need to look for that N, because I can tell you that the average age of we floor ladies is, I don't know, whatever average age, and I can tell you all women are of average age of 55 from this pool. But would that be reflective of if I went down to, a huge gathering where there were thousands of women, right? What would the average age be? Fewer, you might get a different answer. So always look for that when your scientists come and they give you an N. That's what that N is. If the N is 6, it means it's a good start. But an N of 600 is simply more data, right? Closer to the truth. Dissolved oxygen, and I'm just starting to condense stuff down and making different kind of graphs because I can. I have the skill, I have the technology. This is overall, this is Matagorda as a whole. Same type of graphs we saw with oxygen. Oxygen is a lot more variable, just because we're out there when it's cold. These are your minor bays over here, Pascavallo here. Where's Cox and Keller? Cox, Keller, Lavaca, Chocolate, Carampla. And so you can see that dissolved oxygen varies by month and by minor bay. So on that far side, we have Matagorda as a whole, but it's all these little bits together that make up that whole, but you can see the bits aren't the same. So, like I said, that was all we're talking today. It's about the variability in the bays. And turbidities, you see this exact same thing over here as Matagorda Bay as a whole for 40 years. And over here you have it by month. Again, Pascavallo, Cox, Keller, Lavaca, Carampla. Pretty cool stuff, huh? All those make up that. Actually, all those equal that, except for I took out some of the minor bays to make it easier to see. Believe it or not, that's easier. Okay, so biological variability. This is just, I picked a couple critters. Blue crab. You can see it does vary by bay. East Matagorda Bay is this gray dotted line. She's doing her own thing there. You can see they're pretty clustered. This is actually Matagorda. Matagorda is very, very low. We're the lowest, which is weird and awkward, and we do want to find why. And is that maybe what Paul's seeing, is what are the blue crabs eating? Okay? So, but this is something that we would have to look into. You can't just do a straight comparison of Matagorda Bay to San Antonio, because you can see they're not the same, right? Okay, juvenile blue crabs, so these guys come from the same. Blue crayon, if you look at the title, I give you a sample for blue crayons. I'm not sure what a blue crayon is, but I'm pretty sure it's a blue crab. If you look at this funky shape here, I tried to make it so y'all could see it. This is East Matagorda. It's what we catch in a seine, so we're after crabs about this size to adult size. The ones like this, pinch the worst, please. You think it's the big ones, but no. Those little ones are like, I want to live. And they get the tiny bits of your flesh. It is, oh my gosh. I actually had to invent new words for that. I'm not proud of that, incidentally, but sadly true story. West Matagorda is this dark one, and again, you can see we do have a lot lower than you might expect on the Middle Coast. And San Antonio's is pretty fuchsia here, and so you can see. You have seasonal variability in all the bays, but the bays aren't the same. Note your variability. And then this is by sub-bays, and this is the Colorado River. This is Turtle. Yeah, none of our other bays that we traditionally look at was really popping out here on this one. But you can see, if we look at it over 40 years, they come in and go, and we don't really know what's going on with blue crabs these days. Another critter to look at, this is the sand trout from the seines. And you can see, I looked at it, this is total number we sampled by month, total length. So you can even see the length varies a little bit by the minor bay they're in, right? You're gonna find more habitat for small critters the closer you are to the river. It's just how it works. Because there's more little habitat up there, there's all those nutrients we talked about coming in with river flow. That's all up there, so they have a place to live, a free housing, free food. Who wouldn't, if you were a juvenile, go up the river, right? But that's what you'll see as you look at these minor bays, is you'll see they're gonna be further up the river, and you also see they have a seasonal pattern. December, January, February, March, they're pretty much not around, they're like, it's cold! So they move offshore, right? So we're now starting to see that seasonal variability. So we've seen how much type of variability, right? From everything from the planet rotating to, you know, whether we're talking salinity or temperature aren't always doing the same thing. And now here we're seeing that the fish are cold, they don't want to be here, which we all knew. So that's what you're seeing there. You can also, like I said, the lengths change. Average monthly trawl catch. Now this is, we're looking at bigger animals. Remember, seine's the smallest that we sample. Trawl's bigger. That looks like an Atlantic croaker to me. And you can see by, I'm looking at the major bays again. This is Sabine, Blue, Galveston, and this is Matagorda. Cool, right? In that month of June, and this is just for 2020, I forgot I did pull just 2020 for you. So you can look at that big 40-year cluster, but sometimes that doesn't tell you anything because you've averaged so much in. So you need to look at it. And so this we just took 1 year, and you can see Matagorda is leading on croaker. This is us, guys. In June and July, we beat it out of the park, which is kind of fun. I like beating things out of the park. Okay. Then we're also looking at them by minor bay because that's what we good responsible people do. Same data set, just 2020, but now we're looking at it and we saw how Matagorda dominated in June and July. Now we're starting to look at, well, what minor bay dominated in June and July. And so what do you see? Cox. This red is Cox. And then this is just the general open part of Matagorda. And this is Karumpwa. So you can see Matagorda was dominated by Cox Bay that month in 2020. Do you like my data? That's why I said, so anytime we're learning new stuff, keep in mind all this as your background material about the variability. Because, you know, you don't want to make all the ecologists twitch when they're talking to you, right? This is just something else we look at. Not only do you have, like, that critters will be at a certain location at a certain time, but they're different sizes. So it doesn't show as much here. This is big Matagorda, not the cluster, but it's not any of the minor bay. It's right out below Lavaca. That's what we call Matagorda in this, when we're talking about minor bays. But you can see most of the stuff was not in the minor bays, like not up near the headwaters. They were down in the big body of the bay, okay? So, and you can see that the size changes at different months and different minor bays. And you can see 220 is Lavaca Bay. And so you can see it was a huge contributor and probably was just feeding the lower bays. That's why you see, oh, I have that backwards. But anyway, there you go. So you do see how you can't just look at Matagorda. Matagorda from this is a compilation of all these minor bays. And to make informed decisions, you need to know that. Now this, can anybody tell what that Rorschach test is? Right? It's actually, this is Latin long. So this is Matagorda Bay proper, minor bay 360, call it Matagorda, out east arm of Matagorda. This is Lavaca. This is Cox. That's Caronqua, Crescalacious. But that was the data, it's just how turbid is it? But when you see those bigger dots, it means it's more turbid overall for 2020. But if you start to figure out where your rivers are, you have the intercoastal coming in, you have a little bit of freshwater, and it's also where like you can have points, right, on your bay. I just did this for fun because I wanted to make you do a Rorschach test. But you can start to see is just putting up that visual, you can almost figure out where either your rivers are or your points. Can't you? Cool stuff. It's like, you know, I'm a bio nerd. Now this is a graph I showed you a year ago, but it was the same kind of thing. It's redfish lengths. I had only 30 years of data there, just because I wanted to play. And you can see that there is variability in just redfish length by bay. And again, we're going back to that big Matagorda as being a proper bay. You can see average redfish catch per unit effort varies by season, by minor bay. So fall is brown, spring is green. This is 30 years of data all bunched together. Caronqua, Chocolate, Cox, Keller, Lavaca, Powderhorn, Redfish Lake, Lavaca, Swan Lake. You can see there's a seasonal pattern, and you can see there's a minor bay pattern. The variability is great. This is just catch per unit effort by minor bays in a different format. Not seasonal, squinched together, but you can see if you squinch seasonal data together, you do get an average. It can tell you something, but you better know what your data you're looking at. And this is lengths by minor bay in a different format. Length frequency, you can see the length changes depending on your minor bay. Is here you have more of this 3 to 350 millimeter size. You know, if you go to past TPWD, shocker, they're, you know, you have more, that's more individuals caught, more coming in. So you see a lot of different stuff when you look at the data. And then the Gulf killifish, I did give you a background for this in a Rorschach test, although I didn't till the very last minute. You guys were so lucky that my biologist was in the office. And you can see this is just what we would call bait, but the reason I introduced you to bait, say hi bait. Hi bait. Come on guys, hi bait. The reason I introduced you to bait is, you know, you've talked to me repeatedly about what Paul Montagna shows and his concerns. So one of the things is, you know, you have to look at that. So I was looking at something lower in the trophic level, lower in that food web, so that would be more connected directly to some of his work. So that's why I picked this guy. This is the Gulf killifish, and you can see his catch is pretty uniform around the bays, except for what is notably purple. This is Matagorda, some of Galveston, some of Sabine. It's really interesting data. We're actually, this data is so interesting to my biology geek self because there's some voids, but it's always, there's a void of data here, a void of data there, a void of data there. It's not that there's a void of data we didn't sample. You saw the rest of my little colored maps before. What it is they're not there. So I called my biologist in. He was hating on me the other day. Dave! So Dave came. I said, look at this. What do you see? Well, why? He's like, well, there are different bays. I'm like, no, we need to dig in this. This will actually probably become a paper. So when I'm showing you all this stuff and you're like, yeah, the thing is we geeks, we science geeks, this actually will probably become a paper because it's so neat that it's always about the same orientation of the bay, the western side of the bay, the bigger bays, but it's not down in San Antonio. This needs more science. I'm so excited. So, I'm coming over here and talk to you some more science. Hey, you know, that's what I do, guys. I brought you the squid just because squids are funny. We do offshore samples. This is offshore Gulf trawls. Well, it's all trawls, so we combine the Gulf and the bait. And you can just see where we catch them and less likely to find them, you know, up near the Guadalupe Delta. You know, where it's fresher, they're less likely to be. We knew that, so you almost never see them up in Sabine. Down here, up there it's too fresh, down here it's too what? Salty. They're an invertebrate, they don't have anything to protect them. I'm a squid, you know? I'm gonna ink you. Selene doesn't care. So, you know, that's just some of our data, again, trying to look at different species. So what I want you to take home from this is you didn't learn anything new. I know you didn't. But as you're stewarding Lavaca Bay, because that's what you guys are, you're the essential stewards to keep that wonderful resource alive. You're gonna hear a lot of scientists, you already have, you've been at this for a couple of years, right? 3, 4, 5?
2018,
I can't even count that high anymore.
4.
Okay, so but you guys have been doing it, but as good stewards, sometimes you encounter people like me and we look at you and we twitch, and you know that there's a disconnect. And some of it is this, is people say Matagorda Bay is. Have I taught you what? Matagorda Bay is highly variable. There are times it is entirely fair and reasonable to say Matagorda versus Sabine or Matagorda versus San Antonio, but you better know what you're saying when you're gonna get scientists engaged to try to help you. We want to back your play. I need good stewards. I'm not allowed to advocate. You guys are. I want you out there. But this is how you connect to scientists, is you know why we're twitching. And then you can address that, right? So we're highly variable. You have the large scale influences like tides, El Nino, La Nina. You have your seasonal influences. You have your intermittent influence like tropical storm, winter storm. I proved to you you have local influences, right? Freshwater inflow, that was driving your salinity. Bay geography, like that paper we're gonna write. Size of the bay, we actually think has some issues. Vegetation has issues. Where they are along the coast. Hey, if you're, you know, further up in the latitude, you're gonna be colder. And all of this and more influences critter distribution. So that was my message for you today. And do you have any questions?